Hello, welcome to this video on the multiple choice that you did yesterday. Let's try and do probably 5 questions. Let's do batches of 5 because otherwise the video will be too long. All right, so we've got to arrange these. This is question 1, by the way. We have to arrange these in order from most negative to most positive. Okay, so very quickly, let's see what they're all about. The first one is bond breaking, so that's going to be endo. Second one is bond forming, so that's going to be exothermic. Third one is bond forming, that's going to be exo. And S is bond breaking, so that's going to be endo. So the most negative, that's going to be the 2 exos. All right, and obviously the most positive are going to be the 2 endos. So which ones are they? Q and R must be on the left. So this is Q and R on the left and R and Q. So the answer is either B or C. Okay, so I thought we were going to crack it just with that, but we have to go a little bit further. Breaking a bromine is going to be endo. It's going to cost me 193. Making a chlorine is going to give me 244, this one. What are we doing here? We're making a CCl. CCl is minus 340. Okay, so this one. So already we know the most the most exothermic, in other words, the most negative is going to be R. So this must be the answer, C. So the answer to number 1 is C. Let me pause the video and do number 2. Okay, this is number 2. We've given 2 enthalpy changes and we have to using those, give the enthalpy change of formation of iodine trifluoride. Okay, so the first thing I want to do is write down the equation for the enthalpy of formation. I want to write the equation for this down. So the way I did this on the right, start off on the right, we start off with that on the solid and work backwards. Well, I'm going to need iodine in the solid state plus chlorine in the gaseous state. Now I want to balance it. This is going to be half of that and 3/2 of that. So this is the one I need. I've got to use these 2 equations. Somehow I've got to manipulate these 2 equations to make this equation. Now, as I can see, I need iodine on the left, so I'm going to use this one as it is. Okay, but I need half an iodine solid. So I'm going to times that one by a half. So this is, I'm going to call this equation 1 and equation 2. This is equation 2. Let me do equation 1 in a minute. So this is I2 solid. It's going to give half I2 gas. And the plus 38 is going to be divided by 2 as well. Okay, so that's going to give me plus 19 for that one. All right, let's do number 1. Well, I know when I add my new number 1 and my new number 2, they have to add together to give this. Okay, so I've got half an iodine gas, so I want this as a half as well. So I'm going to times the top one by a half as well. Half iodine gas plus 3/2 chlorines gives ICl3, and this is minus 214/2, which is 107, minus 107, isn't it? If I add these together, let's try and add them magically with this. The iodine gas is going to cancel with the iodine gas, and then we're going to get half I2, which is this, plus 3/2 Cl, gives me ICl3, which is what we want. It's this one, isn't it? The formation. Now I've got to add these 2 together. I've done the work. I've divided them both by 2 already. So that's going to be plus, it's going to be, what is that going to be? Minus 88, isn't it? So the answer is 2B. Hope that makes sense. Let me pause the video. Okay, number 3. This is number 3. This is about oxidation numbers. Okay, so what are the changes in oxidation numbers of the 2 nitrogen atoms in this when the reaction proceeds? Okay, so let's redraw the equation. NH4, ammonium nitrate, gives one of these nitrogen oxides. That's water. There we are. That's the first thing. Oh, I'm getting a notification. Apparently Aston Villa is playing tomorrow. All right, so let's do the oxidation numbers here. This one, well, 4 hydrogens are plus 4. It's got to go, the charge on an ammonium ion is plus 1, so the nitrogen must be minus 3 there. In the nitrate ion, The charge is -1. 2 -2 times 3 is -6. I've got to go from -6 to -1. So the nitrogen must be +5 in that one. So nitrogen exists in two oxidation states on the left. Okay, on the right, this is -2 for oxygen. So each nitrogen must be +1. So one of the nitrogens has gone from -3 to +1. That's an increase of +4. The other nitrogen from the nitrate has gone from +5 to +1. That's -4. So the answer is D. So the answer is 3D. Hope that makes sense. Let me stop the video. Okay, we have to use these. We have to manipulate these four equations, and we've got to try and get the second ionization energy of sodium. So what is it? Let's write down what the ionization energy of sodium is. The second ionization energy. It is Na plus gas. It's going to give me Na2 plus gas plus an electron. That's the delta H second ionization energy. Okay, so how do we get that? Right, on the left we need an Na plus, and on the right we need an Na2 plus. So, well, I want everything in a gas, so that doesn't look good because I'm not going to use Z at all because there's a solid there. I'm not going to use this one because there's a solid there. That's nothing to do with ionization. So we're going to manipulate W and X only. Okay, so even before I do anything, the answer must be B because they're the only ones with the bits and pieces we need. Okay, so what am I going to do then? I need sodium gas on the left, so I've got to reverse W, and let's have a look at what minus W will look like. It will look like Na plus gas plus an electron gives me Na gas. This is minus W. This is minus this one. Okay, let's have a look at this one. This is going to be Na gas. I'm not going to reverse X at all. Na gas gives me Na2 plus gas plus 2 electrons. All right. Now, what can I cancel out? Well, this is going to cancel with this. Oops, done the wrong one. Sorry, let me stop that. There you go. What are we doing? Now, this is going to cancel with this. This electron is going to cancel with one of those. And if I add these two together, I get Na plus, this thing, gives me Na2 plus 1 electron. And how did I do it? Well, I added together equation X and I took away equation W. So the answer must be B. All right, I think that's number 3, but let's have a look. Okay, this one looks quite straightforward. This is number 5, by the way. I got it wrong last time. I said it was number 3, but it was number 4. But this is number 5. All right, by using the standard enthalpy changes of combustion, what's the value of the formation? In other words, what's this? Okay, now let me write it down here in a bit of space. 4 carbons plus 5 hydrogens give me 1 butane. We're combusting them, so it's going to give me combustion products down here. It's going to give me 4 carbon dioxides and 5 waters. Okay, and that will give me the same. Okay, so let's call this the one we want, delta HR. I'm going to call it delta HR. I'm going to call this delta H1, this delta H2. Delta HR is equal to going from here to here, and then from here to here. So it's delta H1 minus delta H2. What is delta H1? Well, it's 4 times the combustion of carbon, which is minus 394. I'm going to put that in brackets, plus, where are we? 5 combustions of hydrogen. So 5 minus 286. All of that is delta H1 minus delta H2 is the combustion of butane, which is minus 2877. If you do that, now I've got a calculator. I didn't want to do any calculations, but there you go. 399 times 4 is equal to that, plus 5 times 286 is equal to that. So all of this stuff in here, delta H1 gives me minus 3026 plus 2877. So plus 2877 gives me something totally wrong. So let's try that again. Oopsie daisy, let me start again. 2877 minus 3026 should give me the answer. I get, I get minus 149. I think I've done something wrong. I can't see what I've done wrong at the moment. That shouldn't be, that's not, I said this is 399. It's not, is it? It's 394. Let's start again. 4 times 394 is equal to that, plus 5 times 286 is equal to that. So I get this. This is wrong. I get 3006 minus. Okay, so let's do that again. So we have 2877 minus 3006, and I get minus 129. So I get the answer as B there. Okay, minus 129. Okay, sorry for that, but I couldn't read my own writing there. All right, so 5B. Oh, this one looks awful, but we got to do them, haven't we? This is number 6. I have no idea what's happened to my pen. Let me make this bigger. Hold on, guys. I'll make that smaller. It's a weird thing. This is Google Whiteboard or Microsoft. Sorry, Microsoft Whiteboard, and it does odd things. Okay, 1 second. I'm nearly there. 103%. That will do. In a calorimetric experiment, 1.6 grams of the fuel are burned. 45% of the energy is released is absorbed by the water, by the 200 Gs of water. Temperature rises from 1866. The specific capacity of water is that. What is the total energy released per gram? Okay, so let's go. So as we know, the energy given out, Q, is equal to mc delta T. M is the water, the mass of the water, times C, which is 4.2, times the temperature difference, 56, 46, 48 is that, isn't it? So that's the amount of energy given out, I think, unless I'm wrong. Looks all right to me. Okay, so 200 times 4.2 times 48. Okay, I get here 40,320 joules given off. Okay, now that's per 1.6 grams, isn't it? Okay, that's not per gram. So now, and this is per gram, that's a bit of a mean of them, isn't it? So per gram, well, it's that number divided by 1.6. So, gosh, is it that much? 40,320 divided by 1.6. Yeah, 25,000. So 25,200. Okay, that's the number of joules per gram of the hydrocarbon. It says it's only 45% efficient. Okay, so it wants the total energy. So in other words, 25,200 joules represents 45%. So what represents 100%? Well, that's X joules, isn't it? Go up here. X is equal to 25,200 times 100 divided by 45. I'm sure you could have done it quicker than me, couldn't you? So times that by 100. My calculator is a bit weird. Is equal to that divided by 45. Now I'm going to divide that by 1,000 because it gives the answer in joules and I want kilojoules. And I get, oh no, it wants it to keep in joules. And I get 56,000 joules. So I get B. Okay, so the answer for this one is B. All right, let me pause the video for the next one. At last, an easy one. Which equation is the enthalpy change of atomization? Atomization is going from the standard state. Whoops, let me make that a bit bigger. Okay, make this a bit smaller. This pastes very strangely, this whiteboard. All right, so this is an easy one, as I say. Atomization is going from the standard state to the atoms. Okay, so we can get rid of the ones not standard, could be this, could be this. Okay, now we want to form 1 mole of atom, so the answer is C. Piece of cake. So the answer is C for that one. Let me pause the video. Okay, this one looks awful, but they're not. These are quite straightforward. I've got to find out the enthalpy change of this reaction using bond energies. Okay, so what are we going to do? We've got to, I draw these, otherwise I get confused. Okay, so carbon monoxide plus 2 hydrogens gives me CH3OH. There you go, gives me methanol. So I've got to break bonds on this side, and that's going to be endothermic. And then I've got to, I get bonds formed, that's going to be exothermic. And then I add the two terms together, and I should get the answer. All right, so I break a carbon monoxide, which is 1077. And I break two hydrogens. Where's hydrogen? This one. So that's going to be 436. And I'm going to do that now while I'm here. So that's 1077 plus 2 times 436, 1949 I get. Okay, I hope it's right. So that's going to be endothermic. Now, what are we going to get out of it? Right, we're going to get 3 CH bonds. Where's my CH? This one. 410. Whoops, 410. There's a CO bond here. Where's my CO? 360. And there's an OH bond. And where's my OH? 460. So I'm going to add all of these up. This is 3 times 410 equals that, plus 360 plus 460. And I get 2050. So this is going to be exothermic because it's bond forming. Add these two terms together, add that term and that term. Hopefully, we're going to get the answer. So we've got 1949 minus 2050, and I get minus 101. So I get B for this one. Okay, let me pause the video. Okay, I think this is number 8 or 9. Anyway, the reaction pathway diagram shows illustrates the energies of reactants, products, and the transition state of reaction. What expression represents the activation energy for the forward reaction? So in other words, I'm going that way. Okay, this is the activation energy for the forward reaction, and that's E1 minus E2. E1 minus E2. That was quite straightforward. So the answer to that one is A. Okay, this one looks a little bit confusing, but there we are. Right, now it says use of the data booklet is relevant to the question, and we needed this information from the data booklet, which is the ionization energies of calcium. Okay, that's what we needed. Okay, so here we go. Basically, we've got to give this using these two and the first and the second ionization of calcium. Okay, so let's do that first. Right, from calcium gas to a calcium plus gas plus an electron apparently is 590. Okay, and then going from calcium plus gas to calcium 2 plus gas plus another electron, the second ionization energy is 1150. Okay, now if you add these two together, we'll get the relationship we need, I think. All right, so let's get rid of that. That will cancel with that, obviously. And what have we got left? I think that's right. So we're going to have Ca gas. It's going to give me Ca2 plus 2 electrons. There's gas there. Plus 2 electrons. Add these two numbers together. That's 0, 4, carry 1, 7, 1. I think 1740 plus. Okay, now I'm going to use these equations here. Right, I've got to get this, don't I? So what do I need there? Well, I need this equation. All right, so calcium solid goes to calcium gas, and that's 177. Okay, now I want, where am I now? I want the aqueous and the 2 electrons, but let's do this one. So this one, I'm going to write it again. Ca2 plus gas plus aqueous gives me Ca2 plus aqueous. Okay, and now, and that's good. Everything's good so far. And this is minus 1565. And now I'm going to use my friend here, the one I've just found out. Okay, the one I've just got now. Now, what do I want to cancel out? I want to cancel out my Ca2 plus. So I just write it as it is, actually. I'm surprised. So we're going to write this one as it is. I hope I'm getting this right. Ca gas gives me Ca2 plus 2 electrons. And I found out this is plus 1740. Now let's add it all together. This is the exciting bit. So Ca2 plus gas there. That is going to cancel with that. So we're good so far. Okay, calcium gas, that is going to cancel with that. So we're good so far. And what are we left with? Ca solid, this one, plus aqueous, this one. So far, so good. I can shift the electrons over to that side. Minus 2 electrons gives me Ca2 plus aqueous. So all I've got to do, quite a long one really, I've got to add these three together and I should get my answer. So here we go. 177 minus 1565 plus 1740. And I get plus 352. I get that as the answer. I think this is number 10. I'm going to stop the video now and I'll do the other 10 in a different video.